Next part we're going to do is talk about some very important properties in mathematics: commutative, associative, and distributive. Commutative comes from the word commute, which means to move. So the commutative property states that the order in which two real numbers are added or multiplied does not affect the sum or the product. So we can move the terms around. So if we look at our commutative property here, a plus b is the same as b plus a. 5 plus 7 is the same as 7 plus 5. Moving the order of those terms does not make a difference in the applied sum. The same is true for multiplication. 5 times 7 is the same times 5. And if we add in more addition or more multiplication, the same property holds true. The associative property comes from the word to associate. Associate is your group, who you hang out with. So when we regroup the numbers within addition or multiplication, it does not affect the sum or product. And we can see that if I have a plus b in a grouping, and then I'm adding c, it doesn't matter if I change that grouping and I add b and c first in order and then add a. This is just an extension really of the commutative property. And so we can see that 5 plus 7 is 12, plus 2 is 14, versus 7 plus 2 is 9, plus 5 is still 14. And the same holds true within our multiplication. And last, and probably the most common property that we'll use is our distributive property, which we've talked about before. It's just that multiplication distributes over addition. So again, when we have this grouping, we can distribute, and every term within the expression gets that multiplication. So let's go ahead and use these properties for a couple different things. Using our commutative and associative property, use the commutative property of addition to write an equivalent expression. So we need to look for the addition, and we say, okay, well, we're going to switch places of the things that are being added. 7x is being added to 5, and so what we can do is switch the order and say we have 5 plus 7x instead. Same thing here, we can switch the order of these terms, and we get 13x plus 8. What you do not want to do is we do not want to change just the numerical values and leave the variable alone, because it does not equal if we had 13 plus 8x. That's the first thing you do not want to do. The second thing you do not want to do is change the order of the values within the multiplication, because now we're applying the commutative property of multiplication. If it asked for multiplication, we could do that, but it's not. So we just want to make sure that we're not writing it as 8 plus x times 13. While it is an equivalent expression, it did not apply the commutative property of addition. Associative property of multiplication. We're looking at what's being multiplied to write an equivalent expression, and then simplify if we can. So we'll start by changing our association. We don't want to move the values of anything. We just want to change where the grouping is located. So we have 4 times 9 equals y. And since they asked us to simplify, we can go ahead and do that and get 36y. If we do it again here, we'll change the association, 3 times 11, and then we can go ahead and simplify to 33b. Next, we'll cover our distributive property. We distribute over addition, and so we go ahead and multiply 3 times 2x plus 3 times y, which gives us 6x plus 3y. This is assumed to be a negative 1, so we'll distribute that negative 1. Negative 1 times 3x minus negative 1 times 1 gives us 3x plus 1. Get that a little neater. 3x plus 1. We have multiple factors, but we can go ahead and we will distribute both of those factors. So 0.07a times b minus 0.07a times 2 gives us 0.07ab minus 0.14a.